using the simplex algorithm. So we're going to go through this using an example, and we want to maximize 8x1 plus 5x2 subject to the constraints x1 plus x2 is less than or equal to 6, 9x1 plus 5x2 is less than or equal to 45, and x1 and x2 are both non-negative. So the first step we're going to do is we're going to put this into standard form. So we want to maximize, actually just before we do this, if we say that we want to maximize profit, for example, then that will be equal to 8x1 plus 5x2. So here we want to maximize p minus 8x1 minus 5x2 x2 is an x equal to 0. This will enable us to put it into the simplex, and this is subject to x1 plus x2, and then we want our constraints to be equal, all equalities. So to do this, we're going to add in slack variables. So our first slack variable is going to be called s1, and because we've added this in, we can now say that it is equal to 6. And we will choose s1 such that x1 plus x2 plus s1 is equal to 6. We can then do the same with the other constraint. This time we're going to add s2, and then x1, x2, s1 and s2 are all non-negative. So now we can put this into a tableau. So the headings for the columns are going to be p, then our variables x1 and x2, s1, s2. Then we're going to have our right hand side with the equation, so 0, 6, 45. We're going to have a column for the ratio, one for method. These headings are interchangeable depending on who is doing the question. As long as you have the same method, then the headings don't matter too much. For example, some people put P over on them, just to the left of the right hand side column. So let's now put our standard form linear programming problem into the table. So start off with the objective function, 1 lot of p, negative 8 lots of x1, negative 5 lots of x2, no s1, no s2, and the right hand side is 0. Right, let's do that in a different colour. For the constraints, we've got no p's at all. And then the first constraint is 1x1, 1x2, 1s1, no s2 equal to 6, and then 9, 5, 0, 1, 45. And I'm just going to put in here method 1, 2, 3, because they are our first 3 equations, as it were. So the first thing we're going to do, or the next thing we're going to do, is to pick the most negative value in the objective function, which is going to be minus 8. And based on this column, we're going to work out the ratio, hence the ratio column. So of the constraints, we want to do the right hand side divided by the value in the column. So 6 over 1, which is 6, and 45 over 9, which is 5. Now here we want to pick the lowest positive value, which is the 5. So we're going to circle in the column that we picked, in the pivot column and the pivot row, which is where the 5 is, we're going to circle the 9. This is going to be our pivot. So if we now extend the table a bit, take our next 3 equations, so this is going to be equation 4, 5 and 6, Now looking at the pivot row is number 3, and we want to keep the equations in the same order. So 6 is going to be equal to 3, and then we want to divide by the pivot, so divide by 9. So this will give us 0, 1, 5 over 9, 0, 1 over 9, and 5. Then using the pivot row, we want to make equation 1 and equation 2 to have 0 in the column of x1. So we'll start with column 2, over here. So what we want to do is take column 2 and we're going to take away row 2, and we're going to take away row 6. So that will give us 0 minus 0 is equal to 0, 1 minus 1 is 0, 1 minus 5 ninths is 4 ninths, 1 minus 0 is 1, 0 minus a ninth is 1 ninth, and then 6 minus 5 is 1. Now for the objective, so equation 4 is equal to 1 plus 8 lots of equation 6. Oops. This will enable us to get this minus 8 to be 0. So we're going to have 1 plus 8 lots of 0, which is 1, minus 8 plus 8 lots of 1 is 0, minus 5 plus 8 lots of 5 ninths is negative 5 ninths, naught and naught is naught at 8 ninths. This is very easy to make mistakes now, just through small arithmetic errors, so make sure you check your values carefully, and then the right hand side of this row is now going to be 40. Now we will keep doing these iterations until we have no negative values in the objective function. So because we have a negative value here, which is negative 5 ninths, then we will continue. So we'll do exactly the same thing again. We select our column, and then we want to work out the ratios. So here we're going to have 1 divided by 4 ninths is 9 over 4, and 5 divided by 5 ninths is 9. Now, obviously here we're going to pick the smallest positive value, which is going to be the 9 over 4. So 4 ninths is going to be our pivot. And all we'll do then is do the same row operations for equations 7, 8, and 9, where number 8 was the pivot row. So we'll divide it all by 4 ninths, which will give us 0, 0, 1, 9 over 4, and negative a quarter, with the right hand side being 9 over 4. Yep, so rather than solving the whole simplex, because that could take some time, sometimes it can be many iterations, I'll give you the final solution, or the final tableau, and let you work out the rest of the steps. So the final tableau will be 1, 0, 0, 5 over 4, 3 over 4, 165 over 4, then 0, 1, 0, negative 5 over 4, 1 over 4, 15 over 4, oops, finally 0, 0, 1, 9 over 4, negative a quarter, 9 over 4. So because we have no negative terms in the objective function, Sorry, that should have been in green. No negative values in the objective function, then that is our optimal tableau, and we can simply read it off where P is equal to 165 over 4, with x1 being 15 over 4 and x2 equals 9 over 4. So you can see this x1 is 165 over 4, 2 15 over 4, and P 165 over 4, x1 15 over 4, x2 9 over 4. And that is how you solve the simplex algorithm for a standard linear programming problem. Thank you for watching.